How's it going, everybody? Welcome back to Make It and Break It. My name's Andrew, and I'm standing next to our fabrication cart. We built this fairly recently here on the channel to help us with some of our problems with tool space. You can see we've managed to cram a few useful tools in a relatively small and mobile space, as well as get our fabrication capabilities up and running, because we're finally going to start doing real fabrication for our projects. First thing up is finishing this. So this is the templating tool we made for our skid plate for the Project HyperTenere Yamaha R6. You can watch that somewhere up here, whatever side and or location that those bubbles pop up at this point in time. And we want to make out of something that resembles this. So this is a sheet of 1/8 inch steel. Typically these things are made out of like 1/8 inch aluminum, which will save you some weight, but we might make this out of steel just because. Anyway, we're gonna make this out of, a sheet of 1/8 inch material, which means we need to somehow form stuff that comes like this into a shape that comes like this. And to do that, there's a couple ways to do it. I could go buy a tool that lets me kind of position things at angles and do all that sort of stuff and set everything and take hours and hours measuring it. But that doesn't sound like fun, nor does it really fit with what I want to do on this channel, which is advantage some new technology to create a easier time of it in my own garage and show you how to do it in yours. So instead of using magnets and swivels and everything like that, what we're actually going to do is do something very similar to what we did here. We're going to create our own pattern that we can use when we cut this thing up to set everything in place, so that everything's in place and we can just weld it all on up. So I'll show you how we do that. Let's get on the computer. Okay, hopefully this all works. I've changed up a few of the settings, so it might or may not break on me. But here we go. This is our solution. It ended up being more of a fabrication jig than I originally intended. A jig being a reusable assembly or piece or something that helps you locate pieces for when you're building them. So this ended up being more of a fabrication jig than I intended, but it's showing a really cool use of 3D printing for fabrication here. And so the kind of idea is we can slide the various individual pieces into these slots here, and these slots are designed to be used so that they locate the pieces in the appropriate spot. This would be locating the main part here, and this is the front section here. We use these to locate everything and then tack them all together. And this assembly right here is kind of what it's going to look like in real life. So I reassembled it onto our fitment tool here just to show you how everything assembles. You have your two front pieces here, and then 4 pieces mostly to maintain level with the centerpiece here. And the idea is this is all going to be cut out of singular pieces of metal. So this top piece is going to be its own piece of metal. These side pieces are going to be their own pieces of metal here and here. This front transition piece and this front face plate are going to be their own pieces of metal. And then both of these side pieces here, and then their mirrors on the other side are going to be their own pieces of metal. It might change a little bit, kind of depending on what we come up with when we're cutting them out, but essentially it's designed to hold all of these main pieces in place and let us attack the seams. So when we're going to weld, let me grab something here. For example, when we're going to weld, we can go in and tack these corners, here, 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 come in on these corners, here, here, and here, and here, and probably we'll also put these things in place and tack these things in so that they don't move along these edges here. And then we just slide at least these back ones off, and we finish up welding. So, a couple things to keep in mind when you're doing this. Don't be like me. If you have all of the pieces of your assembly designed, you might as well just check them to make sure they fit. I didn't do that with the first two back pieces that I designed. And that makes it really hard for them to fit and work. These would not work. You can see the angles were off. The way I was designing them was flawed, and I didn't catch that until like the third iteration. Also, note that because of the way these two front pieces are designed, these were some problems with the print that I had a failure in print, but they formed enough to make a good demonstration object. These front pieces, you're actually going to have to destroy them to get them off. So on a real metal part that doesn't bend, these ones may or may not come off when they're full strength. Like this one. So this one doesn't bend nearly as much as this one does. So we may or may not have to cut these off in order to get them off. If I'd been thinking ahead of time, I would have adjusted for that in the design. Make them truly reusable, because you might as well if you're going to go through the effort. That also would have made them take less time printing, in all likelihood. But didn't, so here we are. So I think we're going to call that it for today's episode of Make It and Break It. Next time, we're probably going to be using these to make this out of this. Are you excited? Because I'm excited. Are you scared? Because I'm scared. My aluminum welding is complete perfection. Anyway, thanks for watching, guys. My name's Andrew. This is another Make and Break It YouTube video. Like, comment, subscribe, do all the YouTube things. Be sure to hit that bell icon so you get notified when we put out a new video. Thanks for watching, and we'll catch you later.